Hi everyone, welcome back to the channel. So the question is, we have a spherical shell and there is a charge Q which is uniformly distributed on this shell. And then there is a point charge Q0 at the center of the shell. So there will be electric forces here due to the electric charges and the fields. And then the shell will expand from R1 to let's say some other radius R2. Then the question is, how much work will be done by these electric forces to expand the shell from R1 to R2? Okay, so that's the question. Again, this has some concepts, that's why I've chosen this question. And since I've covered one electrostats lecture series, so this will be a nice question to cover right now. And I hope that you will get some learning from here. Okay, so let's get into this. So what all work will be done because of forces here? So we clearly see that since Q0 is at the center of the shell, therefore, because of Q0, there is a potential at R1. We have potential at R1, and then eventually it will go to, let's say, potential R2. Okay, so there is a work done here in changing the potential. So let's call that W1. Okay, change. Now you know that potential because of Q0 at any R is constant, because at that particular R in that circle or sphere the potential is constant because the potential is directly proportional to 1 by R. So in any direction it will be same. Okay. What is the other work that we require to be done? So here if you see, the charge Q is distributed initially for, let's say, shell of radius R1, and then eventually it will be distributed for the same shell for R2. Okay, so there is a redistribution happening, right? You see that? So there'll be work done in spreading the charge, which is Q here, over a larger area. Okay, now let's call this W2. This one was change in potential due to Q0, and this is due to Q. Okay, so I hope you see this. There are two kinds of work being done here. One is because of Q0, another one is because of Q. Okay, now let's compute these two work, and if we add them, then we should be getting the exactly how much work will be required to be done. Okay, so the first one should be simple. So what is the potential at R1? So that is Q0 by 4 pi epsilon naught R1. And what is the potential at R2? That is again same, Q0 by 4 pi epsilon naught, this time R2. And hence the change in potential Q0 by 4 pi epsilon naught 1 by R1 minus 1 by R2. Okay, therefore work done will be Q delta V, because Q is the charge for which we are changing the potential. So the work one will be Q into delta V, hence W1 is Q0 by 4 pi epsilon naught 1 by R1 minus 1 by R2. Okay, so this is the work done. Okay, now let's compute the work 2. What is work 2? So work 2 is work done in spreading the charges over a larger area, right? So the first question that we should ask is, what is the electric field due to a shell, okay, with charge, let's say Q. Okay, so in my previous lecture, I have covered this for a large sheet and also a conductor. But let's understand how to compute the electric field due to a shell containing charge. Okay. Okay, so let's say the charge is Q. Okay, what is the electric field outside a conductor? So we covered that part, is given by sigma by epsilon naught, where sigma is charge. Okay, so this is the electric field given at any point outside the conductor, and the inside, this is, let's say, outside, the electric field will be 0. This is Gauss law. Okay, but here, why would any element on the shell experience a force, or why would there be a pressure from inside when you put a charge Q here on a shell? Why would there be a pressure from inside to expand this shell? It is because if you take a small area here, let's say delta A, then if you see my lecture, the previous lecture, I have clearly written one fact which you should remember, is that force on any area, let's say here delta A, is due to the electric fields for all charges except the charge on delta A, right? This was clearly covered. So there are so much other area here left apart from delta A, and there is this charge density everywhere. So they will apply a force here, okay, because of their electric field. So we need to calculate the electric field because of everything except this delta A. So let's say E1 is electric field due to all area, basically sigma is spread over all area except delta A. And let's also say that E2 is electric field due to delta A. Okay. Now the force on QA will be because of E1, right? Not because of E2, right? We just need to consider the force on delta A as, let's say force on delta A will be sigma into delta A into the electric field because of all other charges. So E1, not E1 plus E2, right? Okay, so this is so far so good. Now, what is the electric field inside? So that will be E1 minus E2, and that is 0. Therefore, E1 is equal to E2. And since total electric field is E1 plus E2 equal to sigma by epsilon naught here, because for a conductor carrying a charge Q, the electric field outside is sigma by epsilon naught. Therefore, E1 equal to E2 equal to sigma by 2 epsilon naught. And if we take this E1 and put it here, then F delta A will become sigma delta A sigma by 2 epsilon naught, and therefore force delta A by delta A is sigma square by 2 epsilon naught. Okay. So this is the expression for the force, which is pretty typical. You might already be knowing this, good to prove it like this because you understand the concept behind it. Let's consider the shell of radius x at any moment, right? At any moment. X which is greater than R1 and less than R2. Okay. So what is the sigma here at this point in time? Q by 4 pi x square. And hence therefore the force per unit area is sigma square by 2 epsilon naught from here, right? Therefore force into area delta A for the entire shell will be sigma square by 2 epsilon naught 4 pi x square. And what is sigma? Sigma is this. So q square by 4 pi x square whole square into 2 epsilon naught into 4 pi x square, right? And therefore this let's say call this total force. So Ft is then q square by 8 pi epsilon naught x square, right? Therefore the delta W work that we need to do to go from x to, let's say, x plus dx will be Ft dx, and that will be q square by 8 pi epsilon naught x square dx, and therefore the total work 2 will be just integration of this from 0 to W2 q square by 8 pi epsilon naught, they are constant, and dx by x square from R1 to R2, right? And which is nothing but q square by 8 pi epsilon naught 1 by R1 minus 1 by R2. And therefore the total work will be W1 plus W2, which is q0 by 4 pi epsilon naught 1 by R1 minus 1 by R2 plus q square by 8 pi epsilon naught 1 by R1 minus 1 by R2. Hence, we can simplify this like this: q0 plus q by 2 4 pi epsilon naught 1 by R1 minus 1 by R2. That's the final expression for the total work done. Okay. So I hope you got few concepts here again. Few important things to note here is that the electric field due to shell, which is containing charge q, outside of it is sigma by 2 epsilon naught. I hope you enjoyed this video. Please subscribe to the channel and like the video, and please share it with your friends. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.